Hello everyone, so we'll be working on question 7 now. This question has a function that we have to implement, and the context of this is we have someone who's locked in an office building and she needs to collect at least three security badges to make her way out. And then this office, I guess, is represented by a bunch of arrays similar to a matrix, and ones are where the badges are and zeros are where nothing is. Yeah, so we can kind of imagine this as like a grid world. And basically our function is just trying to figure out how many possible ways we can get all three badges. So we see in this example given in the question here, if we're given this specific grid, our function should output 5 because we have 5 different paths. So such as like right, down, down, or right, down, or right, down, right, and so on. So let's first, before we go into the questions, let's take a look at what we're given here. So we're already given the fact that we have to use a helper function, which is very helpful. And we commonly know that we're gonna have to call, or we're gonna have to return the helper function's result, as we do in a lot of different problems in this class. We can also kind of infer that we might have to do something recursively, as we know that the style of this question kind of makes it so that it seems, I guess for the first look of how I would do it is we have different paths we can take, right? So a recursive call could possibly go through all those different cases. And it seems our code doesn't seem like a very iterative approach. So we can kind of assume, especially if you're taking an exam, this is most likely a recursive problem. So based on that knowledge, let's get into part A. So fill in the blank, which is this blank right here. And so if rows is greater than or equal to the length of the grid, or columns is equal to the greater length of the grid, what do we return? So in this case, this is basically saying we're going out of bounds, right? The bounds of the grid, the length of the grid, and length of the rows and length of the columns, right, are bounds. And if we exceed that, that means we're outside of bounds. So in that case, we want to return nothing because we don't want to, I guess, recurse over stuff that's outside of our grid, right? And this also can be our base case where our recursive functions can end. This kind of can show us where this question is going, because we can kind of think of our recursive function calls as moving throughout the grid, right? And once we get to a boundary, then we should stop. Yeah, based on that, let's go to question B. Badges plus equals something here. Yeah, and basically the number of badges we can take, instead of just saying like 1 or 0, we don't necessarily know what's in our grid, right? So a definitive way we can actually get the number of badges we have, right, is calling grid row column, which access, or not calls, just call, which accesses what our element here is, like for example 1 or 0, right? And then if we have a 1, that would just add 1 badge to our function or our implementation here. So that's kind of pretty straightforward in that sense. And I guess we can also see where we can kind of get this answer in this right here. We know that badges has to be an integer, right? Because we're comparing it to the number 3. So the safest way to achieve getting each, like the actual number of badges we have, is through grid row column, which just accesses each one. And kind of like based on how we're doing our recursion, we know that we're not going to go over a single tile or a single like part of the grid multiple times. Okay, moving on to part C. This is kind of where it gets a little tricky, and this is kind of where, as a test taker, you would probably want to think of the other parts of the question as well. Yeah, so as we like kind of traverse recursively, we always want to think of like a stop and ending spot, right? So in our code, there's actually probably different ways to do this, but the most straightforward way we can think of going is starting here. Oops, change the color. Starting here, like the top left corner, and then ending here, right? And then we kind of like go through all like different possible paths, right? And I guess this if statement basically checks if we're at the end. And as we can see here, we have two return statements here. And we also know that if badges is greater than or equal to 3, we have to do something. And we know that if badges is greater than or equal to 3, that means we've like achieved a path, right? So we can kind of say that this can be where we write our stopping point. So we know we're at our stopping point if row is greater or equal to length of the grid minus 1, since we don't want to go out of bounds, and column is equal to same thing, length of grid 0 minus 1. Yeah, so that's the answer to the letter C. And from this intuition, we can actually answer G, because since we know that we're starting at right here, or we're stopping at the end here, we should probably start at 0, 0, right? Where our spot is here, where our row and column elements are at 0, and we have no badges. Again, remember, we are using a helper function, and similarly to how we do in class, if we define a helper function within a larger function, it's pretty common to put it right here at the most outside return statement. And I guess I'll go more into why the rest of these are wrong later on, but we can go on to the letter D first. So next, if badges is greater or equal to 3, we return something. So this can possibly be a little tricky. As similar to like other recursive problems, we don't want to just call it the recursive problem like by itself. Usually we have like an addition of recursive results. And if we, for example, I feel like as test takers, the most probable like thought they have would be to return like a different number other than 1, which is the answer, which we'll get to. But the reason why it's 1 is because later on, we're basically checking each possible path, right? And each possible path, we can't like find the number of paths in just one recursive cycle, if that makes sense. Or if I like draw it out right here, if we have like a path like this, right? That's like, we can call that we can like think of as a one recursive cycle. That in itself is only going to give us one path, right? And we want an addition of all of these paths together. So as we kind of think of how we're going to write our function, we want to just return 1 here because we know that it's going to be added with multiple other paths. And this right here signifies the finishing of just one path. And similarly, the else statement, we can say it's 0 because we know that we didn't find a path if the badges is not equal to or not greater than or equal to 3, right? And after we kind of think through this, part F should come along more logically. Again, remember, as we said, we want to add the number of paths together, right? Or the number of recursive cycles that result in 1. And the way we can do that is starting here. At each possible point, we can either go left or we can either go to the column or the row, right? And so the way we increment that is kind of like row plus 1 or column plus 1. And at every point, we have that option to go this way or this way. Especially since we're starting at this corner right here, we don't want to go like backwards or anything. So those are the only two options we have. And the way we would write this recursively is helper, row, and then column plus 1, and then badges. So we keep track of how many badges we still have. And helper plus helper, row plus 1, column, and then badges right here. So basically, let's say we go through, we're starting at the first point right here, right? And then we go through this function, right? So, or how about we start here? So we already have a 1 that we know of, and so that means our badges is equal to 1, right? And now we have 2 possible paths we can go to recurse through. Now we go here with our badges being 1, and then we go here with our badges equal to 1. And now we just keep going on that cycle, and basically that should enable us to find every possible path to this final destination here. And because we're keeping track of the returns in which we talked about in part D and E, this should result in what we're returning the number of paths, if that makes sense. So going on back to G, we know that we're starting at the top left corner, right? Yeah, so I can kind of explain why the other ones won't make sense. This one, it starts at the top left, but we're not starting off with 3 security badges, right? So that would not be the answer. This one right here, helper length of grid -1 and length of grid -1, 0. Because this wouldn't make sense because we're already ending at that point, right? So if we determined that we're already ending that in part C, then we're not really going anywhere. So this wouldn't be the answer. And similarly here, and also because we don't want badges to be equal to 3. Students would probably be most confused about kind of like where to start, especially as personally as I would solve this, I would kind of think of where we would start first, right? Or how we would implement this helper first. And there is probably a different implementation of this where you could start at the bottom right. But in our case here, this would be probably the simplest logic. And as a test taker, I think it's probably better to kind of break it into parts before going too deep into it and thinking of immediately of how we implement each thing, and more of kind of like each step. Usually these problems are structured in a way where you can kind of pick up clues from each step. And yeah, so this is how you would answer this question.